Welcome to the session on trigonometric functions, review exercises. The objectives for this session are to sketch the graphs of sine, cosine or tangent functions, solve equations involving sine, cos or tan, and solve trigonometric equations in radians. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Before we have a go at the first exercise, let's remind ourselves a little bit of graphs of sine, cosine and tangent functions. These graphs are always periodic. This means they repeat themselves after a certain interval. So now let's have a go at the first exercise. So let's solve example 1a. Sketch the graph of y equals sine theta in the interval minus 360 degrees is less than or equal to x is less than or equal to 360 degrees. This should look something like the graph you can see on your screen now. What about example 1b? You're required to sketch the graph of y equals cosx in the interval minus 180 degrees to 270 degrees. This looks something like this. Now if cos 60 degrees equals 0.5, then using the graph find one other value of x for which cos x equals 0.5. Here we've sketched the graph or the line of y equals 0.5. As you can see, it cuts the graph of cos x twice in this diagram. Once at 60 degrees and once at minus 60 degrees. So cos of minus 60 degrees is equal to 0.5. Solving quadratic equations in sine theta, cos theta or tan theta may give rise to two sets of solutions. So for example, consider the equation 6 cos squared x minus cos x minus 2 equals 0. Factorizing gives us 2 cos x plus 1 times 3 cos x minus 2 equals 0. Then setting each factor equal to 0 gives either 2 cos x plus 1 equals 0 or 3 cos x minus 2 equals 0. Bearing this example in mind, let's take a look at exercise 2a. We are required to solve for theta in the interval 0 less than or equal to theta less than or equal to 360 degrees, the equation 10 cos squared theta minus 17 cos theta plus 3 equals 0. So let's solve this. Now 10 cos squared theta minus 17 cos theta plus 3 equals 0 implies 2 cos theta minus 3 times 5 cos theta minus 1 equals 0. Therefore, either cos theta equals 3 over 2 or cos theta equals 1 over 5. Now cos theta equals 3 over 2 has no solutions, since 3 over 2 is greater than 1, and the maximum for cos is 1. So we have to work with cos theta equals 1 over 5. If cos theta equals 1 over 5, the principal value is cos inverse of 1 over 5, which is equal to 78.5 degrees. Now, recall that cos is positive in the first and fourth quadrants, as you can see from the cast diagram. So cos of the angle is either in this quadrant, the first one, as you can see, or the fourth one. So theta equals 78.5 degrees, which is the principal value, or 281.5 degrees, which is 360 degrees minus 78.5 degrees. Now let's solve exercise 2b. We are required to solve for theta in the interval the equation sine squared theta minus 45 degrees equals 1 over 4 for theta between 0 and 360 degrees. So let's solve this. If sine squared of theta minus 45 degrees equals 1 over 4, then we have that sine theta minus 45 degrees equals plus or minus a half. So, sine theta minus 45 degrees equals a half, or sine theta minus 45 degrees equals minus a half. Considering the first case, where sine of the angle equals a half, we have that theta minus 45 degrees equals 30 degrees. Now, sine is positive in the first and second quadrants in the cast diagram. So therefore, we have sine 30 degrees in the first quadrant and sine 30 degrees in the second quadrant as shown. But of course in the second quadrant we can't call it 30 degrees. So here's 30 degrees in the first quadrant, and this 30 degrees here is actually 150 degrees in the second quadrant. In other words, 180 minus 30 degrees. Now let's find the other solutions. If sine theta minus 45 degrees equals minus a half, then theta minus 45 degrees equals minus 30 degrees. And sine, remember, is negative in the third and fourth quadrants. We can see this from the cast diagram. Therefore, theta minus 45 degrees equals 330 degrees, which is minus 30 degrees, as you can see, or 210 degrees, which represents this angle here, because sine is negative in this quadrant. And where does 210 degrees come from? It's 180 degrees plus 30 degrees. So the solutions are theta equals 75 degrees, 195 degrees, 375 degrees, and 255 degrees. Notice that we're only looking in the interval from 0 to 360 degrees. Therefore, we rule out 375 degrees because this is greater than 360. So in fact, theta equals 75, 195, or 255 degrees. We can solve trig equations in degrees and radians using the same methods. So let's now take a look at exercise 3. We are required to find the solutions of the equation cos theta equals 0.3 in the interval 0 less than or equal to theta less than or equal to 2 pi. So let's solve this. Here's our graph of cos in the given interval. Here's the point y equals 0.3. We can use a calculator to find that theta equals 1.266 radians. So if we draw a line y equals 0.3 across the graph as shown, then we can find the solution theta equals 1.266, which takes cos theta to 0.3. As you can see, there are other solutions in this range, or in particular, there's one other solution in this range. So if the given distance on the graph is 1.266, then by symmetry, 1.26 can also be seen on the other side of the graph as shown. So the other solution will be 2 pi minus 1.266. Now cos theta equals 0.3 is where the line y equals 0.3 intersects the curve. Therefore, theta equals 1.266 radians and theta equals 2 pi minus 1.266 radians, which is of course equal to 5.017 radians. Let's now take a look at another example. Solve for theta in the interval the equation sine squared of theta minus pi by 4 equals 1 over 4 in the interval 0 less than or equal to theta less than or equal to 2 pi. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. Of course, sine squared theta minus pi by 4 equals 1 over 4 implies that sine theta minus pi by 4 equals either plus or minus a half. So we have either of these two expressions highlighted in red. If we consider sine theta minus pi by 4 equals plus a half, then we have that theta minus pi by 4 equals pi by 6 as one of the solutions. Now sine, of course, is positive in the first and second quadrants. Therefore, theta minus pi by 4 equals pi by 6 or 5 pi by 6, which of course is pi minus pi by 6. When sine theta minus pi by 4 equals minus a half, then we have that theta minus pi by 4 equals minus pi by 6. Sine is negative in the third and fourth quadrants. Therefore, theta minus pi by 4 equals either 11 pi by 6 here. Here, of course, we've subtracted pi by 6 from 2 pi, or 7 pi by 6, which is pi plus pi by 6. And so if we solve for theta, we obtain that theta equals 5 pi by 12. Here, of course, we've solved the equation theta minus pi by 4 equals pi by 6. Or we obtain theta equals 13 pi by 12 from the equation theta minus pi by 4 equals 5 pi by 6. or theta equals 25 pi over 12, which is obtained by solving theta minus pi by 4 equals 11 pi by 6, or theta equals 17 pi by 12, which is obtained by solving theta minus pi by 4 equals 7 pi by 6. Notice that theta must be in the range 0 less than or equal to theta less than or equal to 2 pi. However, out of all these solutions, there is one solution which is not in this range, namely 25 pi by 12, so we exclude this from our set of solutions. So the solutions for theta are those highlighted on your screen in red. This brings us to the end of this session. If you have understood its contents, you should be able to sketch the graphs of sine, cosine or tangent functions, solve equations involving sine, cos or tan, and solve trigonometric equations in radians. Thank you very much for listening.